Okay, so this is our first video of factor markets and market failures, and we're going to learn a little bit about the first topic here in this lecture video. So the first thing to understand is that we have up to this point been talking about what are called product markets, right? Product markets, and those are for goods and services, final goods or intermediate goods, doesn't really matter. But these are for the things that normally we purchase. So when people buy, for example, McDonald's, they're buying a cheeseburger. That's the final good or service. So for our purposes, most of the semester we've spent on product markets. But in this unit, we're going to look at factor markets. And just as a quick refresher, we had 4 factors of production. We had land, labor, capital, and entrepreneurship. Now, I told you in the very beginning of the semester that entrepreneurship we don't trade, so it's intangible, so we're not going to have markets in that, but we are going to have land markets, labor markets, and capital markets. Now, a couple of weirdnesses. We don't use the name price for these 3. We call them rent or wage. And sometimes you'll see capital actually for its price will be listed as interest with a lowercase I, abbreviated. But usually we're going to use W and R, and W for wage for labor markets, and R for rent for land markets. Now, at this point, we're going to kind of switch gears a little bit and talk about factor demand and factor supply. We're going to do that while we draw a graph. So just to keep it tangible for us, I'm going to use a factor that you're familiar with, like labor. So we're going to draw, just like before, it's going to look like supply and demand, but we're going to have quantity of labor. And we'll just write up here in case we're not sure, labor market, right? And here, remember, we don't use P, we're going to use W for wage. Now, I'm going to use the information that's listed up here in factor demand and annotate it, and I think it's a good idea for you to annotate yours as well to explain what's happening in the graph. Now, for the graph, for demand, here it says demand is the same as derived from marginal revenue product. That's abbreviated MRP. And that's the marginal product of an input, so like the marginal product of a worker, times the price of whatever they're producing. Now, if we think about way back a couple of units ago, we made paper chains. And the first worker made, we'll say, 5 paper chains. So they made 5 paper chains. I'm just going to kind of say this, marginal product, quantity of labor, first worker, 5. And we'll say the paper chains cost $3. So the MRP of the first worker was 5 times 3 equals 15. And the second worker generated, we'll say, 7 units. Now, why did the second worker generate more? Hopefully you can answer that. It's specialization. And if we multiply that times 3, we find the MRP goes up to 21. Now, the third worker might have fallen back down to 5. Why did it fall? Diminishing marginal returns. And the fourth worker, maybe they generated only 3 links times 3 is 9. The fifth worker maybe generated just 1 is 3. So what do we see happening here? 15, 21, then it goes all the way down. As the quantity of labor here goes up, right, we'll see it go up a little bit and then come back down again. And that is our demand for labor. It's equal to the marginal revenue product. So instead of Mr. Darp, we have Dolmerp, if you will, right? We have Dolmerp. And realistically, this is the demand for labor from the perspective of the company, because the company is the one who's hiring the workers. Now, if either one of these 2 things changes, marginal product or the price, that's going to shift the factor demand. Now think about it like this. What would happen if instead of it being $3 a link, it were 6? Well, 5 times 6, and then 7 times 6, 5 times 6, 3 times 6, 1 times 6. So that's 30, 42, 30, 18, and 6. So the MRP is doubled, so that would shift the curve to the right. So if the price goes up, that would shift the curve, right? The price of the good. Now, we're noting the price of the input does not shift the curve, and that would be the wage. So go ahead and annotate, put a star next to that. The wages for the workers don't shift the curve, right? If we had a change in wage, we're just moving from one point to another on the demand curve. So a change in the price of the worker, the wage, doesn't change the demand for that worker, but the change in the price of the underlying product could. Now, what could change that price? Well, it could be maybe all of a sudden people go crazy for paper chains and the demand rises for paper chains. So sometimes we call factor demand derived demand. Derived demand. And that's because the demand for it, for a worker, is derived from the demand for the product that they make. Now, the second thing, they could shift, right? We have the price of the output or the productivity of the worker. Just like here, if instead of being 3 every single time, if we kept the price 3 every time, but we doubled the productivity of the workers. So instead of MP and price of 5, if it were 10 times 3, and then 14 times 3, and then 10 times 3, and then 6 times 3, and then 2 times 3. So we just doubled the marginal product value. That would accomplish the same thing for the MRP. It would say now it's 30, 42, 30, 18, 6. So that would also shift the curve to the right if we had an increase in the productivity of the workers, right, or the machines, or whatever factor we're talking about here, but we're using labor as the example. So the important part, wages don't shift the curve. Wages don't shift the curve, right? Wages don't shift the curve. Now, factor supply. This is going to be a little bit different. Now, this is derived from the willingness to work or provide the factor to the market. Now, we're not going to talk about factor supply for land because realistically, you have a pretty inelastic supply curve for land. For capital, we're going to explore that later in second semester a little bit, but a lot of it depends on savings rates. And so what we're really going to focus on are shifters of the supply for labor. That's what you're going to see most of your questions about. And these are the things that generally could shift labor supply. One way to think about labor supply is this. It's the minimum value that would induce you to get off the couch, right, and go get a job. So if the wage is relatively low, right, you would have very few people who are willing to get off the couch. But as the wage rises, the cost of you sitting on the couch goes up. And so that's considered kind of like the marginal cost of you sitting on the couch. So every time the wage rises, you induce more people to supply their quantity of labor. So we have this nice upward sloping line. Now the wages don't shift the curve, right? The wages are just the price of labor. But what could shift it, there's a few things. Immigration. If you had more immigrants, right, that's more workers who are willing and able to work at every given wage, so that would shift the curve to the right. If you had wealth shocks, so this one's a little bit weird. If people all of a sudden thought, geez, my stock portfolio the stock market tanked, right, and it went down a lot, or maybe their house isn't worth as much as it used to be. If there was a housing crisis, people will work more in response to those because they want to rebuild their wealth, so that would shift the curve to the right. If they're shifting over and joining into the education. If they're deciding, I'm going to pull out of the labor market and go get educated, that could reduce the labor supply. If people decide they have more leisure preferences, that would reduce the labor supply. And cultural values kind of play a role here too. If, for example, in Japan over the last 25 years, it became much more culturally acceptable for women to work, so we saw an increase in the labor supply in Japan. Now, one last weirdness. That the labor curve actually has a little weird tail hook up here. And that's because at a certain point, people actually decide, I'm going to reduce my hours or even just flatline my hours, my supply of labor, or reduce them because they could earn the same amount of money with fewer hours. Now, we're not going to really worry about this range or about this range. So for right now, it's okay if you just have the supply and demand drawn as they are. Sorry about that a little bit. I had to take a quick break. This labor supply curve in coming up like this, it sometimes does confuse students, so I'm going to actually return to that for just a brief second here with a kind of an example from my personal life. So imagine that you have a good old friend of mine, his name is Omar, and he works in a white shoe law firm. And Omar works, right now, he works 70 hours a week. And his wage is $600 an hour. So he makes a lot of money, right? And his boss says, Omar, I'm going to increase your wage to $700. Omar will respond by increasing his hours to 75 hours a week. But at a certain point, Omar kind of flattens out, right? His boss says, how about $800? Will I get more out of you? And Omar says, I'll just work 75 hours. Thanks, boss. And then 900. And at that point, Omar says, I'm going to actually cut back a little bit to 70 hours. That's because at a certain point, he says, I could make the same amount that I used to and work fewer hours. And that happens particularly at higher levels of wages, but it actually happens at lower levels than $800-900 an hour. It can happen in different occupational segments with as low as $40-50 an hour. So it is an interesting side aspect to this. You won't see too many questions about that because for the most part, what we find is that the wages are, the equilibrium wage that's paid is determined by where supply and demand intercept. And what we're going to be concerned with is the equilibrium quantity and wage that are paid like this. We're not going to be up in this range. We're not going to be in this range for the most part. So we're going to stay in the middle of the graph for the most time. So it's okay if when you draw supply and demand that you leave off that and you leave that off as well. It's probably best, if you're going to leave one of them off, just leave that one off. But the MRP, the Dolmerp, almost always has that little hook, that little hooky-doo right there. So, equilibrium wage determined in the labor market by the intersection of the supply and demand for labor. One observation about this is that this is called marginal productivity theory as to why people are paid what they're paid. So within a certain occupational category, maybe it's teachers with 12 years of experience. Within that occupational category, there's going to be very little variance in terms of the equilibrium wage, as long as all the teachers are relatively the same in terms of quality, in terms of the MRP that they generate, and they have relatively similar leisure preferences. The equilibrium wage is going to be pretty much the same. And we find that this idea, marginal productivity theory, that we've just described in this model, is what explains most people's wages. The most of what we get paid is determined by this model. Now, later on in this unit, we're going to talk about other reasons why people are paid what they get paid, but this is at its root why people are paid how much they're paid. They're paid the equilibrium wage from the factor supply and demand graph. Okay, now the second part of today's lecture notes is, what about this idea of if you were a company and you were given a choice between employing a certain number of inputs, maybe a certain number of machines, and a certain number of workers. And you had a budget, and it said how many workers and how many machines should you employ? How many should you hire? There's a simple way to solve it. So it's given here as firms hire the combination of inputs up to the point where MP of R equals MP over W, and we use the whole budget. So to rewrite this, I'm going to rewrite it down here. The MP over the R equals the MP over the W. And this is the marginal product of the labor, and that's the marginal product of the capital. And I'm using K for capital. So let's solve this. This is, by the way, very similar to the marginal utility of good A, of donuts, divided by the price of good A, the donuts, equals the marginal utility of good B, the bagels, over the price of bagels. We've solved this back in Unit 2. So this is just the Unit 5 version of that problem. So here's the total product from each different quantity of machines. Here's the total product from each of these quantity of workers. And we know that we can calculate the marginal product as the change. So we went from 0 machines and 0 total product to 3. So that means the marginal product is 3. The next one, the change is 9, from 3 to 12. Then the next one, the change is 18, 27, 15, and 3. Now let's do the labor side. For these, from 0 to 2 is just 2. From 2 to 8 is 6. 8 to 18 is 10. 18 to 30 is 12. And then 10, and then 2. Now, the wage is 2. Rent is 3. So I'm going to write that here. Rent is 3. Wage equals 2. So MP of K, 3, over R of 3 is 1. 3 over 3 is 1. 9 over 3 is 3. 18 over 3 is 6. 27 over 3 is 9. 15 over 3 is 5. 3 over 3 is 1. Okay? Now this side is 2 over 2, 1. 6 over 2, 3. 10 over 2, 5. 6, 5, and 1. And now we observe our budget is 17, And we're going to look for where NP of K over R equals NP of L over W, and we use the whole budget. So let's start. The very first pair is 1 and 1. Oh, right, problem solved, right? No. 1 worker and 1 machine. How much would that cost? Well, 1 worker would cost us $2. 1 machine would cost us $3. 3 plus 2 is 5. Nope, our budget is 15, so that's not going to be it. Now, let's try the next pair, 3 and 3, okay? So that's 2 machines and 2 workers. 2 workers would cost us $4. 2 machines would cost us $6. 6 plus 4 is $10. Our budget is 17. Nope, not going to be it. Let's try the next pair, 6 and 6. So not 6 and 5, because those don't equal each other, right? 6 and 6. So let's check. That's 4 workers and 3 machines. 4 workers, 4 times 2 is 8. 3 machines is 9. 9 plus 8 is 17. Is that our budget? Yes, it is. That's how many we should employ. We should employ 3 machines and 4 workers. Now, you can test this, actually. You can test it. And here's how. If you went through and you added up, like, how much is our total product per dollar and all of that, and you figured out, like, product per dollar, this is the best combination that uses your $17. And if you don't trust me on it, and which I wouldn't, right? You don't have to trust me on this. You can test out different combinations where you use the entire budget. If you can find other combinations where you use the entire budget, you will not find one where the total product is greater than the 60. That's the 30 plus the 30 that's here. So that's our introduction to factor markets. Hopefully you've taken some good notes. I'll see you next time.